Hey everybody, it is John here with the Cloud Bureau, and today we have a video on understanding Lightning Web Component lifecycle hooks. What do we mean by that? Essentially, when we have a Lightning Web Component, there are three that we're going to focus on, methods that we can declare in a Lightning Web Component that run at particular points of progress in a Lightning Web Component's lifecycle. The first one is the connected callback, and it's a lifecycle hook or an event that fires when a Lightning Web Component is inserted into the DOM. So when it shows up in the DOM, it gets plugged in. The second one is the rendered callback, which fires when the component has rendered. So when it shows, like we actually see it in our UI, and it can fire multiple times based on sort of the changing attributes in our UI. If they're sort of bound to properties in our JavaScript file and those change and it re-renders, then it will fire multiple times. The third one is the disconnected callback, which runs when the Lightning Web Component is removed from the DOM. So when we take it out of the DOM tree, it fires so that we know that it has occurred. Connected callbacks are often used to do initialization of Lightning Web Components, so to set up things when it's inserted into the DOM. Rendered callback can be used to make certain things occur when a component renders or re-renders, although we have to be pretty careful with that, and we'll come to that in a minute. And then a disconnected callback can run when the component is removed. So for example, if we're using platform events, and let's say our Lightning Web Component is subscribing to those platform events, it would do that in a connected callback, and then we would want to clean that up and unsubscribe in a disconnected callback, so often used for that kind of purpose. With that, let's hop in and look at a sample component that I've set up just to demo when and how these lifecycle hooks run. And we're going to start by looking at a JavaScript file or an SFDX project. So here I am in Visual Studio Code, and I have an SFDX project set up, and it has two components in it, a parent component and a child component. The parent component is called component lifecycle, and the child component is simply called child component. For the component lifecycle, if we take a look at the HTML, we have essentially three things that are showing up here depending on the state of our component. First, we have a button that's always going to show up. It's called toggle display, and it's wired or bound to a method called handle display toggle, and it's going to change the value of a Boolean class attribute in our JavaScript file. We also have a text input element where we can put in text, and when we do that, it's going to handle that and pass that value down to the child component. The third one is the child component itself. You can see that defined right here. But it only shows if the value of a Boolean attribute called showChildComponent is true. And again, the toggle button is what changes that to true or false. If it's true, it's going to show our child component, and then it's going to pass in a value called input value to a value on the child called passed in value. And this is to talk a little bit about the rendered callback and why we want to be careful with that. If we look at the JavaScript file, it's pretty simple. We have the input value, which is sort of bound to our input, our text input. We have a Boolean value called showChildComponent, which initializes to false, but changes to the opposite of whatever it currently is when that handle display toggle fires, which is when that button is clicked. And then we have a handle input change event. So when our text input changes, we have a debounced function, so it doesn't run immediately, it waits a little while, and then runs it when we finish putting in a value to our input value and sets it there. Now, importantly, when we set this input value in our debounced function here, it's going to pass that to the child because that, again, is wired in here. If we take a look at that child component and we look at the JavaScript value, we have an API-defined getter and setter for that passed-in value. And so when it changes on the parent, it's going to pass it into our setter, set this private class variable to this, and then this the getter simply returns the value here. We also have two counters, counting the number of times the child component has been connected and rendered. And then we have our three lifecycle hooks and then one helper method. For our lifecycle hooks, we'll look first at connected callback, which is going to run first, again, when that child component is inserted into the DOM. What we're going to do here is increment our connected count variable. We're going to console log the statement connected. We're going to console log the value of the passed in value if it's available at that time. And then we're going to call our helper method logDiv, which is simply going to log the contents of the div element, which we're getting by way of this query selector. Next, the rendered callback will run when the component renders for the first time and then for every successive re-rendering. What it does is it increments the rendered count, and then it console logs a statement, which I have with template literal here, is to tell us how many times this has been rendered. And then again, it's going to call the helper function for logDiv to simply log the contents of our div, which we've gotten by the query selector. Our disconnected callback is going to console log the passed in value, and then it's also going to console log the statement of disconnected. Let's take a look at how this works. Here we have that parent component, and we remember that our display, our sort of conditional display attribute, that Boolean variable on the parent, initializes to false, so we don't see anything here for the child component. It will show up when we click this toggle display. I'm going to do that now, and I want to focus on sort of what happens in the console based on the console log statements that we have defined. So I'll click this, and you'll see that our child component shows up. We see a connected count of 1 and a passed in value of null or undefined because we don't have anything in our input. Over in the console, we see our connected statement. So this is our connected callback function. It runs first, and it's going to tell us that it's connected. It's going to tell us that the input value, which is passed into the child as the passed in value, is undefined. And then it calls our helper function to get the div element and log it. And you'll see here that that is null. An important thing about the DOM, or the elements in our child component, is that when we run the connected callback, they are not yet available, so we don't see anything here. So these first three are tied to our connected callback function. Subsequently, we run our rendered callback, and you can see here that it's rendered 1 times because we incremented the count of the rendered count, and then we ran our helper function. And in this case, because the component has rendered, we do have access via query selector to the div element, which you can see highlighted there, and we can see the internal sort of values for that here. So again, when we connect it for the first time, that div's not going to be available, but when it renders, it will be. The important thing here is that if you're trying to get access to elements declared in your component, at the time of the connected callback, they will not be available. So you can't do things with them here. You have to wait until they are rendered to get them. Now remember that when I change this input value, it's going to change the value on the parent and then set that value on the child because it's passed in via API through the composed component definition. So let's do that here. I'll just put in the word change. And what you're going to see is that the passed in value has updated to change. And importantly, in the console log statement, we get another set of the rendered callback console log statements. So the connected callback did not rerun because we did not reconnect the component, but because we changed the value of the rendered count, which is sort of in there, it's going to run the render and say that it's rendered 2 times. And we still have access to the div element. The important thing here with the rendered callback is that if you want to run logic that is going to affect the UI display at the time of rendering, you're going to produce a situation that is problematic, and I'll show you what that looks like in a second. But before we get there, let's talk about disconnected callback. So remember that our child component shows based on whether or not the value bound to this toggle display is true or false. So if I click it again, it's going to toggle it to false. And you'll see that we log the value of the input, which is still available to that child component at the time of the disconnected callback, and then we run the disconnected statement. If I were to click toggle again, you would see that the connected callback statement runs a second time. At this point, because the input has a value, the value on the child element is available. So in the connected callback, that API value, passed in value, is available at connection. But the div element is gone again because it has not yet been rendered. But then we call the rendered callback again, and the div is available. And here the counter for the rendered callback has reset. So because we remove the child element from the DOM and then reinserted it, it sort of reinstantiates the component, and so our count got reset to 1. Now, just to show you again the rendered callback, every time I change this, it's going to run the rendered callback. And you'll see that it's incrementing that rendered count as 1, 2, 3. And there it would run the 4th time. If I disconnect and reconnect, it resets the rendered count to 1. But again, we have access to the div, but never in the connected callback. All right, let's talk about a danger of the rendered callback, which is related to sort of recursion. So I'm going to hop into my JavaScript file, my SFDX project, and make some changes. On the child component, I'm going to uncomment this, which is simply another paragraph element with a rendered count, and we're wiring the rendered count to it. That's the danger. If I go here and look at this rendered callback, we can see that the rendered count is going to increment every time it's rendered, and then re-show it here. Now, you can probably anticipate that the problem is that if we're constantly changing something that's showing up in the UI, it's constantly re-rendering, and we're going to produce a problematic situation. So let's show you what that looks like. I'm going to deploy this, and we'll go back to our file. I'm going to hard refresh. And I'm going to click toggle display. And what you're going to see in the console is that we've entered an infinite loop. So because we are changing the value of the rendered count class attribute every time the rendered callback runs, and because that rendered count is connected to our child elements UI display, it's changing it and then recalling itself. And so we've entered essentially an infinite loop, and this is a big problem because we can't even close this in Google Chrome. Well, let me close it there. Okay, I'm going to get a new version of this. We'll reopen our developer console, and let's talk about a strategy to mitigate that. I am going to hop back into our SFDX project, and we're going to take a look at the JavaScript file. Now, the problem, as we saw, was that because we were incrementing rendered count, and because rendered count is bound to the HTML template, that every time it was incrementing, it was re-rendering this. It was resetting the rendered count, which shows up in the UI, and so it's again calling the re-rendered, which increments it again, and again produces kind of a vicious cycle, and so we don't want that to occur. If you want to mitigate that in the rendered callback, and you only want to run something the first time that the component has rendered, the way to do that is with another lifecycle control variable. So I'm going to declare a class variable called hasRendered, and I'm going to set that equal to false. In our rendered callback, we're going to wrap this in an if statement, a control flow statement, and say if this hasRendered is not true, that's what my exclamation point doing is saying the opposite. So if it hasn't rendered, then we're going to run this statement. I'll clean this up a little bit. Now, importantly, I also have to, at the first time it's rendered, reset the value of the hasRendered property. So I'll say this hasRendered equals true. And what that's going to do is turn off this functionality, everything in this if statement, after the first time it has rendered. So let's deploy that and go back and take a look at the result. All right, I'm going to toggle my display, and you can see that we have not entered that infinite loop. We've rendered one time, we've connected one time, we don't have a passed in value. If I were to put in an input and change it, essentially nothing's going to happen because the component has re-rendered, but we only wanted to run the logic bound to the rendered callback once. And so by setting that hasRendered value to true, it essentially turns off the logic in the rendered callback and does not call it on subsequent re-renderings. Now, this does mean that you lose access to sort of the incrementation here. We could define a different incrementation for like initial rendering versus not initial rendering to sort of control that life cycle. So for example, I could say that in this case, what we actually want to show in the child component is the value of has rendered. And then in this, we will pull this out and move it out of our if statement so it runs on every rendering. And we'll deploy that. And then we'll go run it again. Again, I've removed the rendered count from its binding to the HTML template. So when I toggle this display this time, we see that the rendered count is true. And then if I were to change this, it would render it 3 times, or 4 times, or 5 times. Understanding the lifecycle hooks and the functions that we can sort of define for those lifecycle hooks is just a basic element of setting up Lightning Web Components, and knowing how to manage them efficiently and without producing recursion is incredibly important. So I hope this video has been helpful. If you find yourself frustrated with lifecycle hooks and trying to understand, we're always here and willing to help over at the Cloud Bureau. Thanks so much.